So, very good evening to one and all present here. I welcome you for the chapter number 2 session on sensors and actuators in a robotics and control system. In the previous segment, we saw about module 1, introduction to electromechanical system. Further continuation to that, we are going to discuss about the difference between sensors and actuators, how these two things are considered to be a vital important component in robotics and control systems. Now let us start with the topic. So sensors and actuators are considered to be the most important component in robotics. So these two will work together in order to enable the robots to interact with the surrounding environment to perform the expected task. The sensors provide information about the external surroundings to the robot, while the actuators translate those signals into physical actions by means of mechanical motions. So what is the purpose of using the sensors in a robotic system? To measure various physical parameters and convert them into electrical signals that the robot can able to interpret by sensing the differences. What are the different types of sensors incorporated in robotic system? External and internal sensors. So what are all the external sensors? So the sensors that is used to measure the environmental conditions like distance, light, intensity, temperature, chemical composition, etc. Internal sensors used to check the position of the component, velocity, speed of the object in terms of velocity, and acceleration force produced to grip the object with the help of the rigid support. So everything which comes under the classification of internal sensor. What are the examples for various types of sensors and the place of location where it is used? Vision sensor. So vision sensor is normally used for object recognition and navigation. To detect an object in front of it and navigate the obstacle, for that purpose, the vision sensors are used. Proximity sensor used to detect the object or obstacles at a particular range or a distance. Force and torque sensor used to measure the force and torque acting on the robot arm. Inertial measurement units measuring the acceleration and angular velocity for producing motion and orientation of the arm. Encoders measuring the position and the speed of the rotating components. So these are the different types of sensors and the corresponding function used for that. What do you mean by an actuator? What is the purpose of actuator? What are the different classification of actuators and the typical applications used? So to convert the electrical signal into a physical motion so that it allows the robot to manipulate its body components to adjust according to the work environment. So what are the different types of actuators? Hydraulic actuators uses high pressurized fluids for producing more force output. Linear actuators. It produces a straight line motion to adjust the arm and leg. Servo motors to provide precise and controlled rotational motion. Pneumatic actuators. It uses high compressed air for power. electrical motors provide various forms of mechanical energy for robotic arm and other components. Let us see some of the few examples. Servo motors are used for controlling the precise joint motion in the robot body assembly. Linear actuators used for controlling the arm and leg movements. Hydraulic actuators used in heavy duty applications and exoskeleton movement of a robot structure. So this is basic things about what is meant by a sensor and actuator. And now, what do you mean by a transduction principle in a sensor? How to define the sensitivity, accuracy, range, resolution, and noise sources in the sensor used in robotic system. Let us discuss. In robotic science, transduction refers to the process where the robot sensor captures the physical stimuli, say for example light, sound or pressure, that will convert into electrical signals so that it can able to further process the data. The key characteristics of sensors, say sensitivity, accuracy, measuring range, resolution, and noise sources, are the critical characteristics for the robot's ability to perceive and react to the environment. Let us see the transduction principle. Robot use sensor to gather the external information about the environment. These sensors are nothing but the transducers, meaning they convert the non-electrical stimuli into electrical signals. Say for example, a vision sensor used in camera that will transduce the light into electrical signal. A microphone transduce the sound waves into electrical signal. How will you measure the sensitivity of the sensor used in robotic system? Sensitivity, it measures how much the output signal tries to change for the given shift in the input signal. High sensitivity means a small shift in the input produces a large change in the output so that it makes it easier to detect the various changes in the environment. How to measure the accuracy of the sensor used in a robotic control system? Accuracy refers to how closely the sensor output reflects the value of the physical quantity that is supposed to be measured. A sensor with a high accuracy provides more reliable data that are close to the actual value. How will you be able to measure the range of the sensor? The range of the sensor specifies the physical value that it can able to measure. Say for example, a range sensor might measure the distance from 0 to 10 meter. The force sensor might measure the force range of 0 to 100 Newton. These are some sample examples. Resolution. Resolution is nothing but the smallest change produced in the output that can be detected and nicely represented by the sensor output. Noise sources. Noise refers to unwanted random fluctuation in the sensor that will interpret that will suppress the electric signal. So these fluctuations can cause obstacle in order to measure the true signal and that lead to inaccurate measurements. So you have to control the noise sources. What are the general application in robotics? The sensor characteristics are critical for robotics to perceive the environment effectively. Say, for example, the sensitivity of the vision sensor. This highly influences how well a robot can detect the objects in a low light conditions. While the accuracy of the range sensor influences how precisely the robot can able to navigate and avoid the obstacles. Now let us see actuators. What are the different types of actuators? Hydraulic and pneumatic actuators. So pneumatic and hydraulic actuators are the two different types in which uh, given a robotic control system used to convert the fluid pressure into a mechanical motion. Pneumatic actuators use a compressed air, while the hydraulic actuators used pressurized fluids like oil. Pneumatic actuators offer better speed and simplicity, making them suitable for applications like factory automation, whereas hydraulic actuators excel in heavy-duty applications which requires very high force, such as construction equipment. What are the key differences and considerations? In terms of fluid sources, pneumatic actuators uses compressed air, while the hydraulic actuators uses pressurized fluids. In terms of force and speed, hydraulic actuators generally require high force to operate, while pneumatic actuators offer faster speed but lower force. In terms of control, pneumatic systems can be easier, simple to control, while hydraulic systems often require more sophisticated control system. So pneumatic actuators are common in applications requirement, especially for lightweight movements such as robotic gripper and arm in manufacturing. Thus, hydraulic actuators preferred for heavy-duty tasks where high force is needed to lift up the construction equipment for industry robots. What are the environmental conditions? Pneumatic systems can be more environmental friendly because it has quite abundance of air, while hydraulic systems require specialized fluids that has to be disposed frequently in a proper way. So with this, I thank you one and all. We will meet in the next module number 3, that is chapter number 3. Thank you once again.